Significance tests. So this is the other part of inference. We've done confidence intervals, and now we're going to do what's called tests of significance. I have misspelled that. C-A-N-C. There we go. That looks better. So, I wonder if that, when it goes to save it, if it'll pick up that A. Maybe won't. So with our chocolate chip cookies, the manufacturer claims that there are an average of 25 chocolate chips per cookie. So their claim, I'll write this out. Their claim, come on, is an average of 25 chocolate. Jeez, what was that? Actions. Eraser. No, I just need to convert to a group. What did I do? Edit. Undo. Edit. Undo. There we go. 25 chocolate chips per cookie. Okay. And we don't think there are. That's what we do with our significance test, is we try to refute someone's claim. So we don't think there's 25 chips per cookie. We don't know how many chips there are per cookie, but we just don't think it's 25. So we think it's not. Okay, so if there are, boy, why is this doing this to me today? Undo. Undo. There. So, if there are if they are, as the manufacturer claims, an average of 25 chocolate chips per cookie, then we could say that the population mean is 25 chips. And if that is true, then what does the sampling distribution look like? Well, the sampling distribution should have a center, same as the population. So the center of the sampling distribution should be 25. The standard deviation of the sampling distribution, well, we're going to have to estimate that using our sample. And we got for our sample standard deviation 4.5. And we had a sample size of 52 cookies. So we'll take 4.5 divided by square root of 52 and get approximately 0.6. And now the shape of the sampling distribution. Now the shape of this sampling distribution gets to be approximately normal because large sample size, central limit theorem. So center is 25. And one standard deviation above the mean would be 25 point. Undo. Edit, undo. There we go. 25.6. Two standard deviations above the mean would be 26.2. One standard deviation below the mean would be 24.4. Two standard deviations below the mean would be 23.8. Three standard deviations would be 23 minus 0.6, 23.2, etc., etc., etc. So our sample, the mean chocolate chips per cookie, was 21.5. Oh, wow. That is, that's way down here somewhere. Way below the mean. Quite a few standard deviations below the mean. So our sample mean, it's kind of like it's an outlier for this sampling distribution. And so when I get a sample that looks like an outlier, I think maybe our original hypothesis was wrong. I think that the population mean may not be 25. Because how often would I get a sample this far away from 25? So if I had gotten a sample like we did last period, they got around 26. Yeah, that's not but 1.5 standard deviations above the mean. That's pretty usual. So that doesn't give me evidence to refute their claim, but this sample mean of 21.5 does give me evidence that maybe their claim is wrong. So let's see how far below the mean this is. Let's figure out how many standard deviations below the mean this 21.5 is. So we'll get a test statistic. And that will be a t, and it'll be the sample minus the mean that we thought divided by the standard error of the mean, and that would be 21.5 minus 25 divided by 0.6. That apparently is negative 5.8, so we're almost 6 standard deviations below the mean. Boy, that's an outlier. Okay, so the probability of getting a sample, the probability of getting a sample this far or farther below the mean is, boy, I wonder how I could figure that out. You actually have a command on your calculator. It's like normal CDF, but we're using a t-distribution this time, so this is going to be a t-CDF. And we got to go way out to negative infinity, and then up to that negative 5.8 is what we're looking at. So we want to figure out, let me make a new drawing of that. There's our t-distribution. Here's negative 5.8 standard deviations below. And then what's the area below that? Better tell, I have to tell TCDF the number of degrees of freedom. We had a sample size of 52, so the degrees of freedom is 51. Throw that in my calculator, and it gives me 2.1 times 10 to the negative 7, which is 0.1, 2, 3, 4, 5, 6, 2, 1, which is essentially 0. So the probability of getting a sample this far from the mean or further, this big of an outlier, if the mean was actually 25, is 0. So boy, I think I got really good evidence that that 25 is not the true population parameter. So let's start to put a procedure together instead of just kind of talking in generalities. So this we'll call the significance a significance test procedure. And we have our step 1, we have the 4 step again. Step one.